Hey, Ilya. I looking through your chapter two exercises, and I can see you're really getting the math in here. But as we go on, it's going to be more and more important that you test out every one of these functions so that you make sure that they work and and that's going to help you in developing better answers and stuff. And testing as you go is really important, especially as you're building more, as you start building more complex things. Okay, so I tested out your general function that you wrote for project 2.5. And I started out, I just set x to 0 and just stuck in, this is one example from the book, 32x, and I got this error message. And the important part of this error message right here is, it says on line 114, and the line has changed because I added in some comments. But anyway, it says on this line, where it says return general function x minus 1 plus I, it says there's a type error because general function takes exactly 3 arguments. Okay, so let's just take a quick review of that, what that problem was, and see what's going on. So I copied in a piece of the problem here. It was said we've been defining quite a few functions via the following skeleton. So we have this general function, and then we have this form. You know, if x is 1, return something, question mark, and otherwise return function x minus 1 plus 2 question marks. Okay, and it says make this skeleton into a generic function generator by introducing 2 more inputs. I think that's an S. B, which is the base case that's going to replace the question mark, and I, the increment that's going to replace the double question mark. Okay, so the F of exercise 2.2, and this is the F basically rewritten in Python. This is the F of exercise 2.2, where it said if x equals 1, return 3, otherwise return f of x minus 1 plus 2. So in this case, the single question mark is the 3, the double question mark is the 2. Is you should be able to just say f and then return generic function 3 comma 2 comma x. Okay, and then it says if you keep b and I constant and you let g of x equal generic function bix, find a simple function defined without recursion that is equal to g on the set of positive integers. Okay. And it looks like you pretty much got the second part, actually. It was the recursive version that wasn't working right. That's this one. So let's take a look at that. So you have the general idea here that you're, well, one thing I noticed is, just for convenience sake, and to make it easier for me to read things, in the problem it asked you to write the function this way: bix, b the base case, I the increment, and x the original x. Okay, so if we can, I'm gonna start by doing that. I'll just I'll call it generic function tj. Okay. And I'm going to put in bi x. Okay. Okay. So I'll give us a little more space here. Yeah. So this looks good here. If x equals 1, return b, because we're going to. Let me just make sure. It says, yeah, because the b is, or the b replaces the question mark, right? So the question, and in our case, yeah, in this case, our B is 3. Okay. All right, cool. So that looks good. The line where we had trouble was this one right here, where you said return. Well, let me just copy it, and then we'll look at it. Where you said return general function x minus 1 plus I. Okay, so that is kind of what we're seeing here, right? General function. But you notice what it says here. It says it tells us this is where we're having a problem, and it says type error general function takes exactly 3 arguments, 1 given. Okay, so when it says here, we want to make this skeleton to a generic function by introducing 2 more inputs. We're introducing these 2 inputs, B and I. Okay, and because we've introduced those 2 inputs, that means that whenever we call this function, and I renamed it, so I'm going to do this. Whenever we call this function, we have to call it with all its inputs. Okay, we've changed this function into a function that needs 3 inputs. All right, so what that means is that we're going to have to then pass down again our B and our I along with our x minus 1. Okay, and then that one should work fine. Okay, and the only thing, like I said, that I would change with your recursive guy is to with your non-recursive version, your closed form, is that I would want to see the inputs in the order that they were given in the book. Just like I said, it just makes it easier for me to read. And then because you've changed these, you're going to have to change. So this is now B, because this is your base case, right? Oh wait, hold on. You know what? I have to test this one out. Let's see. You know what? Before I do this, let me just test out your this one here. Okay, so let's run it. Okay, and I'll show you what I'm talking about too with this. Let's make x equal to 4 this time. And if I say gen function 3 to x, okay, I get an error, and this time it says it's line 147. Okay, and so you see how this tells you the line numbers that you're on. So if we go right here, we're on line 147. So this is where you're having that error with only 1 input. But now if I run this one, where I added the other inputs, if I say now we're good. Okay, we get what we wanted. Another thing is, oh yeah, so let me check this one out now. So See, this is where it's hard for me to tell. Am I supposed to put things in this order, or what do we got? We got a 10. If I try, so it's saying XBI. So if I put in maybe the X first, and then the 3 and the 2, let me see what happens. Yeah. So it looks like you got it. You have a working thing here. It's just the order of your variables. So if we basically did the same thing just to make it nice. Okay. So that looks fine. Okay, so that's all my comments on project 2.5.